AMD's announcement of FSR 3 is absolutely huge, but their official announcement, while it gave us a lot of cool info, didn't give me everything I wanted to know, and it also raised a lot of questions, like what exactly is the difference between like HyperRX? What is it supported on? I'm noticing things like anti-lag plus. What's going on with that? Is there a difference between FSR 3 just upscaling and with fluid motion frames? What GPUs support this exactly? The different pieces, all of that. And I have been scouring the internet for answers to these questions. And while I'm not at Gamescom, a lot of press, media are at Gamescom and are getting meetings with AMD, getting some of this demonstrated hands-on. And in addition to getting it demonstrated, well, maybe not hands-on, because I think they're not actually able to play with the frame generation on, but they're able to see it in person and ask questions. And so I have been able to dig up a whole bunch of information, and I'm about to blind you guys with basically a Google Doc, okay? I never make notes for my videos. This is, I think, the first time I've ever used notes in one of my videos, but it's because I'm pulling a lot of information from different articles and screenshots from different things and all of that. And there's just a lot going on here. So we're gonna go ahead and just like take a look at my notes. What have I been able to pull up here? I'll also mention that one of the best sources I found for this was this Eurogamer article. So many of you might know that Eurogamer and Digital Foundry are affiliated. So if you're more in the YouTube space, you might be more familiar with Digital Foundry. And Digital Foundry did get to talk and see a lot of this directly with AMD. So I got a lot of good info here. Anyway, let's get into all of this. First thing I want to mention is, what do I think is like a criteria for success regarding FSR 3, right? The big question marks are image quality and latency. Because, how should I put this? Because FSR 3 is similar to frame generation from NVIDIA, it's really not increasing the responsiveness of a game, right? It's interpolating frames, which involves delaying showing real frames, and it's giving you increased motion fluidity by inserting those generated frames in between two actual responsive frames from the game engine, right? Which means that the only benefit this technology could provide is an image quality benefit, specifically image quality in motion, an increase to visual perceived smoothness in motion. That's what it has to offer, right? It's not a performance. And I say the same thing about DLSS 3 frame generation. It's not a performance benefit, it's an image quality in motion benefit when it works well. And as we've seen with frame generation, even from DLSS 3 frame generation, it doesn't always work well. Look at my recent test of Immortals of Avium, and you'll see that the UI elements look terrible. Also, just release date-wise, AMD's reveal announcement said early fall release date, but I have seen some text articles I've looked at saying specifically September. So question mark on that. And the initial games will be Immortals of Avium and Forspoken. So for this to be of benefit, its image quality needs to be good enough that you don't lose anything you get from the improved smoothness to visual artifacts. Now, like I said, Digital Foundry's team in that Eurogamer article got to see it in motion, although they did not get to experience the latency because it wasn't them playing the game. They got to see it visually. However, they were very positive about it. And here's a direct quote from the Eurogamer article. It says, "In terms of fluidity and clarity, FSR 3 looked a match for DLSS 3. And this was a view shared by Alex, Rich, and John, who were all present to see the demos in person. A great start for FSR 3. Now that is very good to see, because while I can't see this myself right now, I'm not at Gamescom, many tech journalists aren't people who analyze image quality, specifically like side-by-side game, like image quality, that kind of thing. So, well, that's Digital Foundry's, that's their whole thing, right? Digital Foundry's entire thing is talking about the visuals of the games, also their performance, but right, especially their image quality. So I do take it pretty highly from this source that they are actually claiming that it does look to be in motion comparable, like a match for DLSS 3, right? Great start for FSR 3. That's absolutely huge, I think, especially from that source, especially because Digital Foundry is known as very positive about NVIDIA, right? So I think, if you got this kind of claim from a source that is known as very pro AMD, right? That would be one thing. But I don't think anybody has ever accused Digital Foundry of being, AMD shills. You've heard a lot more of the other way around, right? So them claiming this actually sounds very positive for me, right? Anyway, they did also bring up some questions on compatibility with variable refresh rate and frame pacing when below a VSync locked monitor maximum refresh rate. In the two games demoed, one of them was able to hit the monitor's max refresh rate and VSync to it and had at least to their perception, perfect frame pacing. Whereas the other game demoed, I believe it was Immortals of Avium, did not max out the monitor's refresh rate. And while it was a variable refresh rate monitor, they did see some potential frame pacing issues and VSync kind of stuttering issues with that. So that is a bit of a question mark on that. Also, like I mentioned, one of the big problems with DLSS 3 frame generation is UI elements. In some games it works well, but for example, like I said, Immortals of Avium, when I tested it in my recent video, the targeting reticle, which is right there in the center of your screen, just ghosts all over the place. It's like you get 3 different targeting reticles and they're moving. So it's really bad. However, Immortals of Avium was one of the games being shown off with this technology, and it appeared to handle it well. Here's another quote from the Eurogamer article. Also impressive was that both demos handled UI elements well. Some DLSS 3 titles, especially the early ones, interpolated HUD elements, producing shimmer and motion, but AMD has a range of options open to developers here in ensuring a pleasing static HUD. That is a very good sign, although again, this was 2 very specific games being demoed here, and what I've noticed with DLSS 3 frame generation is that in some games I like it a lot, and in other games it has more visual artifacts and I would leave it off, right? So it's at least good to see that in the demos that were available, this was working well. Also of note is that this is a technology like DLSS 3 frame generation where you would want a high base frame rate for it to work well. And AMD, I've seen quoted from several press outlets, are saying that it does work best with at least a 60 FPS base frame rate to get the best results. That's because if you're interpolating 2 frames, the more similar the 2 frames are, which will be the case, the closer, the higher frame rate you're actually running, there's going to be the more frames you have, the smaller difference between those 2 frames, right? So it's easier to interpolate accurate frames between them, the higher the base frame rate is. Also, the higher your base frame rate, the more responsive the game is, so there's less of a hit to latency. More on latency in a little bit. But how does this actually work? So everything I've been able to find on this says that this does use motion vectors that are in the FSR pipeline, which is also one of the inputs that DLSS 3 frame generation takes, and even just normal DLSS and FSR upscaling use motion vectors as part of the technology for the upscaler. So it's using motion vectors in the FSR pipeline, and it does optical flow analysis using asynchronous compute, and this is where it's very different from DLSS 3 frame generation, and this is where we can get broader GPU support, but also why this might not support every GPU super well. So let's talk about this for a second. So DLSS 3 frame generation, the reason why it is, at least why NVIDIA claims it is exclusive to the 40 series and cannot even work on the 20 or 30 series GPUs, is because the 40 series GPUs have more optical flow accelerators as a dedicated hardware block on the GPU, specifically for performing that task and that task only. AMD's GPUs, to my knowledge, don't have that specific block, and their goal is to support a wide variety of GPUs, including ones that don't. Now, NVIDIA's 20 and 30 series GPUs do also have optical flow acceleration, just not as much as the 40 series, so NVIDIA was claiming that they needed the amount on the 40 series to make it work, and that's their claim for why it is exclusive to that generation. So AMD isn't going to be using that, right? So how are they going to do it? So they are doing optical flow analysis, but they're using asynchronous compute to do it. Now, this has a couple of implications. Number one is that certain GPUs aren't going to have a good ability or any ability to do asynchronous compute. Specifically, I'm thinking of NVIDIA's 10 series GPUs. So like, if you're on a 1060, a 1070, 1080 Ti, and you were hoping for good FSR 3 support, it's looking like you might be out of luck, because NVIDIA's 10 series famously at the time, or at least people super, maybe not that famous, really super nerdy GPU enthusiasts like myself and probably some of my viewers were aware that NVIDIA's 10 series cards did not have a great asynchronous compute implementation. Anyway, so that's why AMD, I was able to find this in a WCCF Tech article. They didn't claim exactly where the source came from, but they are saying this appears to be from AMD with their support list for FSR 3 with upscaling and frame generation. Also note there's FSR 3 without frame generation. So let's talk about that. But anyway, let's look at the support for the frame generation aspect of this. AMD's 5700 and above is supported, although not recommended. Recommended is AMD's RX 6000 series and above. So if you're on something like an RX 480, RX 580, something like that, and you were hoping for this technology to help you out, it's looking like that is not actually going to be the case. NVIDIA GPUs, looks like 20 series supported but not recommended, and the 30 series and above are actually recommended. So that's where we're at with that. Also, it's very interesting to note that it is claimed that because the FSR 3 frame generation will be using the asynchronous compute power of the GPU, this means that in some games it won't work as well because the game itself is using the asynchronous compute. Because some games use asynchronous compute. Some games use it a little bit, some games use it a lot. And so games that are using most of the GPU's asynchronous compute power just to run the game normally aren't going to have the extra headroom to do a good job with the FSR 3 frame generation, and that means it probably won't be able to boost frame rates much in games that use that asynchronous compute for something else. So that's going to be really interesting to keep our eye on and to see how that ends up playing out. But this brings me to the really interesting note, which is that it looks like there is FSR 3 with upscaling only. No frame generation. And this has broader support. It also looks like there's a native AA version of it, which is similar to NVIDIA's DLAA, where you replace the game's TAA implementation with a FSR implementation, but don't upscale the game. You run it at its native resolution, so it's just an alternative to the TAA in the game to boost image quality if it's a better AA than the game's native TAA. Anyway, so let's look at the FSR 3 upscaling only support, and then I'll talk about this a little bit, because I think this might confuse people. So the supported GPU here is AMD Radeon RX 590 and above, and then the recommended is the 5000 series and above. Notice the difference there of 5000 series versus 5700 right there, because there were lower end GPUs in the 5000 series than the 5700. On NVIDIA GPUs, it looks like 10 series and above, so here's where you might get some benefit on your 1060 or your 1080 or something like that. And again, that's supported, but it's recommended for 20 series and above. Okay, so let's talk about this whole FSR 3 with upscaling only versus FSR 3 with upscaling and frame generation, because I think this is going to confuse people. But AMD is just doing the same thing that NVIDIA did, but I think NVIDIA made a mistake with how they marketed and branded DLSS 3. I saw a huge example of this in my recent DLSS 3.5 video, where I explained that. And I see so much of this in the comment section. I actually tried to clarify it in the video, but despite that, my comment section was absolutely full of people who did not understand the distinction between DLSS 3 and DLSS 3 frame generation, because they are not the same thing. And it looks like AMD is doing the same thing here, where FSR 3 has an upscaling component and a frame generation component. and they don't have to be enabled at the same time, and their supported GPUs are different. Okay? So let me explain this also in connection with DLSS 3 frame generation, and I think you'll understand the same thing. There are versions of DLSS 3 upscaling that doesn't include the frame generation, and those are supported on 20 and 30 series GPUs. You can use games that have DLSS 3 upscaling, and now their new ray reconstruction technology will also support the 20 and 30 series GPUs. But what's confusing then is that frame generation is locked to NVIDIA's 40 series. But the other GPUs can still do the upscaling component, which can look better than some of the older versions of DLSS 2 upscaling. So it's a little confusing like this, and I think the problem was the numbering system being confused with a feature set. And so I think this is a confusing branding and numbering system, and the same thing seems to be going on here with FSR 3. I'm actually really excited about this distinction, because to me, this sounds like a lot of people have said, myself included, that FSR 2 upscaling does not look as good as NVIDIA's alternative upscaling in most situations, especially at more aggressive settings and resolutions. This sounds like AMD's FSR 3 is not just FSR 2 plus frame generation. It sounds like they may have, although I can't confirm it, improved their upscaling to a version 3, and then you could also then kick on frame generation on supported hardware. I hope that the FSR 3 with upscaling only is an actual improvement to FSR 2 upscaling. That's my hope reading this, but I couldn't find any direct confirmation of that. That's something an unanswered question I'd still like to see. Is FSR 3 with upscaling only better than FSR 2 with upscaling, right? Do you see what I'm saying? Anyway, hopefully you're not still confused, but I think in general, both GPU brands are messing up the marketing on that distinction. And I think it's just AMD following the naming scheme that NVIDIA introduced, which has confused a lot of people. Anyway, so that's what I've got about GPU support and what I've got about image quality. So the other big question is latency. So here's one thing that's really interesting, is we see this anti-lag plus. Like we see it on screenshots like this, right? It says anti-lag plus. Now, anti-lag is not a new thing, but anti-lag plus appears to be a new thing. And I'm very curious about this, but all the mentions I can find of this in anybody who's talked to AMD about this is that AMD is just not talking much about it. They won't really give any details. So anti-lag plus seems to be exclusive to RDNA 3 though. And I'm very curious how it compares to the normal anti-lag. And again, like I said, AMD did not seem to want to discuss the details with any media. This is absolutely crucial though, because as we've seen with DLSS 3 frame generation, it requires NVIDIA's reflex to cut latency in order to make the latency acceptable. And even then, a lot of people still don't like the added latency, and you do need a high base frame rate for it to be good. Now, I will say personally, using a mouse versus using a controller, the latency tends to be less noticeable. But with the mouse, where you might do such fast movements and you're used to such a quick response on a mouse, it becomes more noticeable. So that's another little kind of subtlety to what is acceptable latency, right? And I think it'll vary for different people. But anyway, what do we know about anti-lag? Well, we know that the normal anti-lag that's been around for a while doesn't cut as much latency as NVIDIA's reflex, but it also runs through AMD's driver, so it doesn't require the same level of direct game integration that NVIDIA's reflex technology does. So in other words, reflex is more effective, but requires more integration versus anti-lag. I am curious if anti-lag plus is maybe somehow more like NVIDIA's reflex, but I have no idea. And like I said, I could not track down any additional info here, but I think not enough people have picked up on this distinction, that there is a new anti-lag plus, and it should be different than anti-lag, right? And what exactly does it mean and how effective is it, right? Also, my thought was, what if you were running FSR 3 on an NVIDIA GPU, like a 20 or 30 series GPU? Let's say you're running it on your 3080, right? You can't run DLSS frame generation, but you can run FSR 3 frame generation. Cool. Since you wouldn't have access to anti-lag because it's a driver level feature, how are you going to deal with the latency? Well, I was also wondering if it's a game that supports NVIDIA's reflex technology, which most games that support DLSS 3 frame, every game that supports DLSS 3 frame generation does have to integrate reflex. So if it's a game that has FSR 3 support and DLSS 3 support, but you're on like a 30 series GPU, you can't actually use DLSS 3, but you could use reflex and then kick on FSR 3, I think I'm wondering if it'll end up actually being a slightly better experience on the 30 series GPUs using reflex than what we get on the AMD 6000 series using anti-lag. That's just a question mark I have in my head. So basically, one of the big question marks we still have here is latency. Because again, even the people that got to see the in-person demonstration of this to look at image quality, they were not able to use it hands-on. And this is where I think the biggest potential problem is actually going to be, is in the latency implementation if AMD does not have something equivalent to reflex. But we'll have to see. Also a big deal will be game support. Now there had been tons of talk about Starfield potentially being the breakout game for FSR 3. But that really does not seem to be the case. It's not one of AMD's listed games. We have Immortals of Avium and Forspoken being the first two that should get support. But then we also have the rest of these games on this list right here, including Cyberpunk, with promised support incoming. And then again, you would hope for a whole bunch more. However, regarding game support, there's something now separate from FSR 3 that I'm not sure enough people are seeing the distinction on, right? So I want to clarify this. Through AMD's HyperRX feature, okay, there appears to be a thing kind of like FSR 3, but worse, except actually better. Except what the heck do I mean by that? This reminds me of the distinction between FSR 1 and RSR. One of them has to be implemented into a game, and the other one is run through the driver. Now let's talk about this, okay? What is going on with HyperRX? First of all, it has a Q1 2024 release date as far as I can track down, which means that we will get actual FSR 3 before we get AMD's fluid motion frames as part of HyperRX through AMD's driver. Also, everything I've been able to find is pointing to HyperRX being exclusive to RDNA 3 GPUs. So AMD's fluid motion frames through the driver are probably also exclusive to RDNA 3 GPUs since it's packaged with HyperRX, which again does seem to be an RDNA 3 exclusive. In other words, this could be an AMD 7000 series only feature. Also, since it runs through their driver, you wouldn't have any support for this feature on NVIDIA or Intel hardware. This would be AMD only. So even if I'm somehow wrong about it being 7000 series only, although all the articles I can find seem to point to it being 7000 series only, it definitely would not be supported on NVIDIA hardware or Intel hardware because it would be run through the driver. And again, as far as I can tell, this appears to be 7000 series. Now, what's going on with this? It basically applies frame generation, AMD fluid motion frames, to nearly every single DX11 and DX12 game. And that is incredible. However, while that is the what's better about it feature, it will be worse than FSR 3, okay? It will be worse. Because it's running through the driver level, it's not going to have access to the motion vector data, which FSR 3 frame generation will be using. Because the FSR 3 generated frames will use motion vectors, they can be more accurate. They will look better. Without that data, this will look worse. But will it look good enough to be usable? That depends on a lot of things. One of them is probably the base frame rate, because the higher frame rate the game is running, again, the easier it is to interpolate the frames in between. This seems more like what TVs are able to do, although it's possible that it will execute it a lot faster than what TVs are able to do. Because TVs can take video and, you've seen the motion smoothing to boost the frame rate, that kind of stuff. There's generally a large latency penalty to that, and this should be faster. Eurogamer article did get hands-on with this. Well, again, I shouldn't say hands-on. They did get to see it in person, but not experience the latency of it. Here's the direct quote, and it's going to be a bit of a longer one here because they had a lot of interesting stuff to say. This says, "We saw it demonstrated on The Last of Us Part 1. So to be clear, Last of Us Part 1, not supporting FSR 3 frame generation, right? So this is the the driver level version, right? And they say, it works. I'm skipping a little bit of their direct quote, but to get into where they say, what we saw in the demo was clearly worthwhile. The bottom line is that we did indeed see The Last of Us Part 1 running at circa 160 frames per second and higher, albeit with VSync off, so there was screen tearing. And they said that they suspect this is because it was running outside of the screen's variable refresh rate range. So again, if this was like a 120 FPS, hertz screen, but you're running the game at 160 FPS, you'll get screen tearing. Right now, AMD Fluid Motion Frames works only with VSync off, but AMD is looking to add VSync support. And again, it's a Q1 2024 release date, so they do have time to get that going. Now, this would be a really big deal because it's very hard when you're almost doubling a game's frame rate sometimes to maintain under your monitor's max refresh rate, which if you don't have VSync support, you would have to stay below your monitor's max refresh rate in order to avoid screen tearing. So this is going to be a really big deal because games generally vary performance wildly from scene to scene. So if you're in an easier to run scene, you might suddenly get screen tearing, which would be bad, right? So that's a big question. Anyway, continuing quotes from the Eurogamer article, we see, similar to the Radeon Boost driver level dynamic resolution scaling feature. I have a video on Radeon Boost on my channel if you want more information on that. A lot of people don't know what that is. But anyway, it says the tech is automatically disabled in response to rapid mouse movement, presumably to prevent obvious visual anomalies that will occur in frame generation when the two source frames have so little in common. So this is interesting. So basically, right, like you can swing a mouse around incredibly fast. And so I guess it will detect that. And because if you're swinging incredibly fast, your two real frames are going to be very, very far apart. And so trying to interpolate a frame in between without any motion vectors available would probably be terrible. So it's cool that they're able to turn that off when it detects that. But my question is, how fast of a mouse movement is required to trigger that? Meaning, how usable will this actually be? Will there, because also, a lot of times it's during fast camera panning first-person mouse movements that you would most want the increased frame rate. So there's a lot of questions about, will the image quality on this be good enough to actually be worth using? Will they get VSync locked in so it doesn't just introduce screen tearing? And if it disables itself when you move your mouse quickly, how useful is it? So a lot of big question marks there. But as I already mentioned, my thoughts are this seems a lot like FSR 1 versus RSR. RSR is basically applying FSR, spatial upscaling to a game through the driver, and it just doesn't work as well as when it's natively integrated into the game. And that seems to be what's going on here. AMD's fluid motion frames, when implemented through the driver, it's really cool to have that option, and that means you could kick it on almost anywhere you want. However, it also means that the quality of it could be lacking, and we'll just really need to get hands-on with it and see how we go. So my final thoughts on all of this are basically, for FSR 3, my biggest question is latency. Image quality is also of concern, but it was nice to at least hear in a not hands-on, but in-person demonstration, people qualified to look at image quality, like the team from Digital Foundry, did find it to be looking good, at least in those AMD-controlled and limited hands-off demonstrations, right? So, but latency is the biggest concern. We'll have to see what comes of that and if Anti-Lag Plus could be something competitive with Reflex in that regard. And my final thoughts on fluid motion frames. I actually have a big final thought on this because while I hate exclusivity and vendor lock, and this is, right, it's run through AMD's driver, so this is an AMD exclusive. Something like HyperRX running AMD fluid motion frames, doing that on every DX11 and DX12 game. If this actually ends up being a good technology, something good enough that you'd actually want to use it, having an exclusive feature that NVIDIA doesn't, and that NVIDIA can't just run on their GPU anyway, like with FSR 3, for example, might be something that AMD honestly needs. Because right now, one of the big selling points for NVIDIA over AMD is NVIDIA's exclusive features. And while I don't like exclusivity, that doesn't mean it doesn't work for selling GPUs, right? Or selling things in general. And so, AMD doing something first rather than being just a follower. FSR 3 is obviously being a follower, right? It's a very late response to DLSS 3 frame generation. And hopefully it ends up actually being good when we get our hands on it. But the idea of pushing it forward with this DX11, DX12, everything through the driver, all of that, that's doing something first. And doing something first and not just being a follower, I think is something AMD needs to do more, right? So while it's clearly very inspired by DLSS 3 frame generation, it is doing something that isn't. Although we're not going to see this until Q1 2024 if they even hit their release date deadline, which is a question mark. And also, again, that depends on it being something you'd actually want to use. So having an exclusive feature that actually just doesn't work very well, that nobody would really want to use, doesn't really do much for you. But if this actually ends up being good, and it's AMD doing something that NVIDIA doesn't, that could be a very good thing for AMD's sales, right? To have some bullet points that the competition doesn't. Okay, guys, this was a long video, but I had a lot to say about it. I'm really excited to see more information on all of these topics. We have seen, some performance numbers and all of that. Are getting some latency numbers from this AMD slide, but it's HyperRX on could also be upscaling, which isn't just cutting latency with Anti-Lag Plus. I've got a lot of questions still, but hopefully this answered some of your questions. Let me know what you guys think about all this in the comment section, and I hope all of you have an excellent day.